Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, for the function, check for discontinuities and make a rough sketch of the curve. So the given function is g at t equals t squared minus 2t minus 15 over t minus 5. Now this function is a rational function, and discontinuities in a rational function can be in the form of a whole or vertical asymptote. Now the first step is to factor the expression in the numerator. Now we cannot factor the expression in the denominator. Now the expression in the numerator is a simple trinomial, so we can factor it using the sum and product rule. So we have to find two numbers whose sum is equal to -2 and product is equal to -15. So the two numbers are -5 and 3. So -5 plus 3 is equal to -2, and -5 times 3 is equal to -15. So now we can write the factored form of the expression in the numerator. So g at t equals the t minus 5 times t plus 3 over t minus 5. So now we can see that binomial t minus 5 exists in the numerator and the denominator, so we can cancel it out. So that means there is a whole in this function. Now to find the t value for this whole, we should set the binomial equal to 0 and solve for t. So we can isolate t in this equation by adding 5 to both sides. So the 5's on the left side get cancelled out and we get t equals 5. So this is the t coordinate of the whole, and now we can rewrite the g at t function as t plus 3. Now we can find the function value at this whole, so we can sub in t as 5 in this function. And 5 plus 3 is equal to 8. So we can conclude that there is a whole at 5, 8. Now in the function equation we got after simplifying it, so we got g at t equals t plus 3. Now as you may know, this is a linear function, and a linear function has no vertical asymptote because there is no t value that will make this function undefined. So we can conclude that this function has no vertical asymptote. Now we can find the critical points for this function. So we'll find the derivative of g at t. So prime of g at t will be equal to, now the derivative of t is equal to 1 and the derivative of 3 is equal to 0. So prime of g at t is equal to 1. So that means there are no t values that will make prime of g at t equal to 0 or undefined. That means this function has no critical points. Now we can find the horizontal asymptote, if any. Now since g at t is a linear function, in its simplified form, there is no horizontal asymptote in a linear function. So that means we can conclude that there is no horizontal asymptote. So now we can make a rough sketch of the curve, and in the curve we'll show the hole on the straight line that represents this linear function g at t equals t plus 3. So if we, so this is the t and this is g at t. So we know that the hole is at 5, 8. So let's assume this is 5. So this is 1, 2, 3, 4. And then let's assume 8 is here. 4, 6, and then 2. So the hole is at this point, 5, 8. So we show it as an empty dot or an empty circle. Now we can sketch the function g at t equals t plus 3. So this is a linear function whose slope is equal to 1, the coefficient of the t term, and the t-intercept here is equal to 3. So the t-intercept is here on the y-axis or the vertical axis, and the slope is equal to 1. So that means the rise over run is equal to 1. So we go 1 unit up and 1 to the right, and then 1 unit up, 1 to the right, and then 1 unit up, 1 to the right, and then another 1 unit up, 1 to the right. So now we can join these points by a straight line. Now this line should not pass through the hole, so it has to like skip over the hole, and we can extend it on the other side. So this can be the sketch of the function g at t. So this point is 5, 8. So that's the hole. So these are the steps you have to keep in mind to solve a problem like this one. So it's very important to analyze the given function carefully. So in this case, we were able to reduce this rational function into a linear function because the binomials t minus 5 cancel each other out. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.